Alright, in this video we're going to talk about making a pocket in the substrate for that flower to go in, and a little bit about rotary tools. Let's do it. So we're ready to temporarily glue this thing down, come in with an X-Acto and scribe around it, and it's very much the same process as with the hand tool only inlay that I demonstrated. I did put some little, probably pretty faint on the camera, but I did put some little general guidelines to help me get this glued in the proper position. I'm just trying to cover up this knot right here. This is an important note, so I'll mention it again. It's going to be really tempting to glue this pattern down, and sometimes there will be circumstances in which that's a good idea. This is the pattern we use to saw to, but this pattern would not be a good fit on how this flower turned out. It's just the nature of the beast. Things change shape, and I don't necessarily trust this anymore at all, so I would not glue this down and Dremel up to it. Although that is an option if you're planning for gaps to be in your image. So this surface is nice and flat. It's been shellacked a few times, so it's pretty shiny. The glue is not going to stick to it real well. I'm going to opt to even put probably a little dab of glue on part 1 and on part 3. And again, since this surface is shellacked, I can get away with quite a bit more glue there. But I want to be pretty careful about that. It would be pretty tragic to be unable to get this piece off without breaking it. So a little drop there, a little drop there. So I've got 2 little drops. I'm making a note to self that those drops of glue are under parts 1 and part 3. I think I like that position pretty well, so I'm just gonna I'll probably hold this for 60 seconds and then give it 5 minutes before I come in with the knife. Pro tip: when the tip of your X-Acto breaks down, which it certainly will, rather than throw that away and get a new one, I would recommend you just grind the dull tip off and just give yourself a new point. You can give yourself a lot more usable edges here. Another little thing you can consider: if you know you are going to need to be making really sharp turns, you'll want to do it at a pretty pointy angle, but you'll pay the price because that tip will be more fragile. That's the price you pay for that maneuverability. And if you're sick of breaking off tips and you don't feel you need the maneuverability, put a slightly more obtuse angle on there. But as you can see, you'll probably get hundreds of tips out of this razor blade, and I pretty much use them right down to the nubbins until there's almost nothing left. Another helpful tip: if you've got an X-Acto rattling around in your little toolbox, good idea to store it like this. Keeps it from damaging itself or damaging other tools. So this has been drying for 2 or 3 minutes now. I'm about ready to start taking my X-Acto blade and tracing its shape, but before I forget, I'm going to give myself a witness mark. This is going to be handy for all the times I'm going to be holding this up to the pocket and just knowing which way it's oriented. There's a tendency, there's a desire to sort of want to mark these lines in one firm stroke, and I find that not to be necessary. I will tend to be really sort of gentle on the first pass or two. I'll overlap, and I want to be sure that I'm not getting stuck in a grain line and pulling the knife off course while also making a really deep cut. You got to think that this is all show surface out here, and we don't want to be making really any super deep cuts in general, and definitely not if they're, you know, following the grain or you slip. So I'll be pretty gentle in those initial passes. I'll always be starting the tip of the blade back into the corners like this, and I'll just be taking my sweet time rotating this thing around. And again, I won't hesitate to hit the same spot gently 5 times. I'm also trying to imagine what that double bevel is doing, in that I'm not allowed to hold this blade perfectly vertical, or it will be offset away from the part by half a blade's width. Another thing worth considering, and I'll show this later, I doubt this is super visible on the camera, but I have a little bit of space underneath some of my parts. Try as I might, I didn't get that thing perfectly flat when I was gluing up this assembly. I probably would have benefited from giving it a light scraping on the back just to kind of even that out. those gaps are things I'm going to try to hold down with my fingers when I come around with the knife in that area. And I also need to watch out that I don't let the knife get underneath there and make a mark that is much too small. It's underneath the part, and that will be obnoxious when I come to cut up to that line with the Dremel. So here we go. So I felt a little click. I was pushing a little bit too hard, lost my tip, so I just jumped out to the bench grinder and ground a new point on there. You'll also notice, this occurred to me right when I started, I'm sort of following a system where I'm going to do this one, kind of however far is comfortable, this one. I'm going to go all the way around and do that, then I'll do the opposite side of the corner, then I'll come in and start the knife on this inside corner and pull it out and meet all the previous ones. You can do whatever you think is convenient, but you'll want to come up with some system to avoid the tragedy of knocking this piece off and coming to find that, like, oh my gosh, I never marked this line right there. It's nearly impossible to put it back in the same spot, so do whatever you have to do to be sure that you're marking everywhere that is relevant. So I took my sweet time with that. I really wanted to be sure that I was getting nice lines, not drifting away from my part, and also not cutting off any of the bottom corner of the sawn parts there. That will lead to some funny business where you're scribing a line that is describing a pocket that's too small. That's very obnoxious later on, so I'm watching out for that. You also, I think, noticed at no point was I ever making a knife cut without supporting it right there with my finger. There's a fine line. You're going to be sort of dragging the knife in such a way that it's riding against the part, and if you are not supporting it, you might scoot the part. That's a big bummer. Don't let that happen. Another thing I was watching out for, I have to consider the direction of the grain of the substrate. In these corners in particular, not so much this one, but these corners where I have a short grain, I perhaps was a little bit less forceful with the knife. I was sure to make a mark all the way into the corner there, and I double checked that I had my tip still going on. My tip was still on my razor, my X-Acto, so I could be sure to get in there, but I didn't really get aggressive in those corners, or I can risk popping out a little nugget of that short grain, and I don't want that. So I got a little bit distracted, and I went and sharpened my X-Acto a few times. I should note, the bench grinder is a really fast and easy way to do this, but you can also just run this on a Waterstone and cut off that dull section and give yourself a nice new point. I'm going to come around with a flashlight and probably even take the knife and just sort of stick it into anywhere that I can't. If I can't see with the flashlight that I for sure made a cut line there, I'll probably stick it in, and you can pretty clearly feel the areas where you have and where you have not made a cut line. I want to be 100% positive I marked the entire periphery here before I knock it off. So I'm pretty positive I've marked all the way around the perimeter. I'm ready to knock this off. If you'll recall, I did make it a point to remember where I put my drops of glue. I know they're under here. So I need to break this glue joint and a glue joint over here, and the best way to do that is by shearing it. I don't want to peel it, I want to shear it off. And there's a handy thing going on with these parts in that this is a piece of copper, as is this. So I'm definitely not going to come in and strike anywhere on the wood. If I can just take something with a nice crisp edge and set it against the metal, I'll give it a little whack horizontally over here, and then I'll give it a whack horizontally over there, and we'll see if I can't shear this glue without doing anything tragic. Okay, I think the whole piece went. Yep. Most of that glue went with the wood. A little bit of it remained on the shellac. That's the beauty of shellacking this surface first. I should note that I'm going to definitely want to scrape this surface before I glue it in. I want to get rid of this glue, I'll get rid of these numbers, any minor discrepancies or glue that flowed out when I was gluing these parts together. That needs to go. I'd like to present the floor of this pocket with a very flat, clean surface under here. I'm always a little bit relieved when I knock the piece off and come to find that I did indeed cut the whole border. Time to chalk those lines. kind of just nail the whole area with chalk, and then I'm going to come in and rub the chalk into the cracks a little bit, force it down into that knife mark. And this is a pretty lovely cut line going on here. I should have no problem seeing this. Exemplary cut line, I think. I hope that comes through on camera. This is going to be lovely to try to Dremel up to. So we are ready to start setting up our Dremel to remove this material. Let's talk about some options there in terms of power tool pocketing. So this is a quote-unquote Dremel rotary tool. It is very much a miniature router. I cut my teeth on learning Inlay with a Dremel, and it's still one of my favorites. One of these, a nice one, can be had for around $100. You can get this really nice Stuart McDonald's StuMac base for around $50. Very nice for micro adjusting to get the heights right. And I come to find that this is very appropriate for pretty much all sorts of inlay. It's really a flexible tool. It's pretty affordable, and it's kind of my go-to. It should be noted that this Dremel and most Dremels will top out at around 35,000 RPM. They do have a good amount of torque, and that's a fair amount of speed. However, when we get into the really super duper tiny end mills, probably some of those won't even come into focus. We've got 1/8 inch end mills all the way down to I think that's like a 15 thousandths, about a 64th of an inch diameter end mill. We're going to be working with 1/8 inch shanks, as are the two other rotary tool options I'm going to discuss. And we'll discuss the pros and cons there, but the Dremel is kind of it's my go-to. The latest rotary tool that I got pretty excited about is something they sort of refer to as a pencil die grinder. So it is a very small tool. This is an air tool, which is a little bit unusual. You might consider that sort of a con. It does marry you to an air compressor. I think it takes about 4 CFM at 90 PSI. The huge benefit of a tool like this is that it can spin at 56,000 RPM. I think some of them go as high as 75. This one was very cheap. It was like $50, maybe another 15 or 20 for this base. Not quite as nice as the StuMac base, but it totally serves the purpose and gets stuff done. That high speed is really where tiny end mills are going to come to life. They really appreciate that high speed. The downside to this is that it does not have a ton of torque. It's really more about ultra high speed. There's very little adjustment. It's pretty much full on or full off. And I would say it probably doesn't run an 1/8 inch end mill quite as well as a Dremel. It's a little bit too much force on there, and it doesn't excel. But if you're getting down into the 16th, 32nd, even smaller than that end mills, you will have a smile pinned to your face after feeling how they run when they're spinning this fast. As diameter decreases on an end mill, RPM wants to increase commensurate to that to keep the tool kind of in its optimum range. And these things can be a real thrill to use with your tiny end mills. So if you think you're into really small work, you might consider picking one of these up. Again, $50, maybe another $15. And if you have compressed air, awesome option. I'm a big fan. So this is another option, and it's kind of in the opposite direction to the direction the die grinder went from the Dremel. The Dremel's sort of in the middle. It's very fast, but sometimes faster is better. It's very torquey, but sometimes more torque is better. So this is a Fordham handpiece. I didn't bother breaking out the rest of the rig. I'm not going to use this, but this attaches to a flex shaft that goes back to a big motor that hangs up. It is turned on by way of a foot pedal. This is a very professional, high-power type tool. You can get these handpieces that will accept a 1/4 inch shank, which the Dremel and the die grinder that I showed do not accept tools that large. So this is getting to be pretty serious when you have a rotary tool that can accept a 1/4 inch shank. Very torquey. You are not going to bog this thing down by roughing or pushing really hard or even putting a large cutter on there. The downside to this, in my mind, is that it only spins to 18,000 RPM, and in my opinion, that's not quite fast enough to make an 1/8 inch cutter real happy, and that is just flat out too slow to make our tiny diameter end mills happy. Another downside to this is that these, with the handpiece and the base and the motor and a motor hanger and the foot pedal and all that, it's going to put you more in the ballpark of like $400 for the kit. So exclusively for inlay, I'm not a real big fan of this system, just because it doesn't spin fast enough in my mind, and that's pretty expensive when you consider that to the Dremel for $100 and the die grinder for $50. But there are a million and one interesting tools that go on here, and this thing really has a ton of power. You can really get pretty aggressive and shove this into the work. Fordham makes a special handpiece that has threads that accept the same Stumac base as the Dremel, so that's handy. But they have other handpieces and other collets, and pretty interesting for other jewelry smithing, metal smithing, woodworking, wood carving tasks. They're a very interesting and flexible tool, but probably wouldn't consider them essential kit for inlay work. All three of these tools are going to be pretty similar in the way that they actually grab onto an end mill, or any cutting tool for that matter. Here you have, some people call it the arbor, I usually call it the spindle. So this is the main member that actually rotates. Here we have an expanding type collet. You'll notice some precision ground angles on here and some slits so that this thing is able to shrink down and grab onto an 1/8" shank tool. This spindle bore here has a matching ground taper that's going to hit right here. The collet nut, which threads onto these spindle threads, is going to have a matching taper for this conical shape up here. And what that means is when you put this into the spindle and you put this nut on top of it and thread it on, the expanding collet gets shoved in and grabs onto tools in a very secure and very concentric and true sort of way. Unlike a drill chuck that's very flexible, it can accept lots of sizes and may not hold them real straight. This thing can only accept one size, in this case 1/8" shank. That's my preferred size of tooling. It can only accept that one size, but it does hold on very tightly and very concentric, very true to the axis of rotation here. And that's critical if you're trying to spin something at 35,000 RPM and not have it vibrate or cut poorly. This is an accessory made by Dremel that I absolutely love. I believe the part number for this is the Dremel part 490. This is the impeller fan collet nut, and it's very much what it looks like. It's a standard collet nut like came with your Dremel, but it has an impeller fan on it such that while you're actually pocketing and wood is getting blown out, this is blowing the dust away and making sure you can still see your line. So I think this was like $4 and totally sweet. Love using it. So let's talk briefly about the cutters I would recommend. I pretty much exclusively use solid carbide spiral end mills, 1/8" shank. And these are kind of made for CNC cutters, and that just means that their quality is higher and they're ground a little bit sharper and truer. The big thing that you're going to want to watch out for, most tools in this size range are going to be 2-flute, and that's absolutely fine. I prefer a 2-flute. You're going to want to avoid things like burrs or diamond cut end mills, things like that. I like just a 2-flute spiral, and I have two different flavors here, and they both have pros and cons. So you'll notice they're very similar. They're both the same diameter. They have about the same cut length. You'll notice the flutes are ground in opposite directions. That is, the spiral that the cutting edge sort of takes to the end is in a different direction. That does not mean that the tool spins a different direction. There's kind of some funny misnomers about if you take a standard upcutting end mill and you spin it backwards, it becomes a downcutting end mill. That's not a thing. That's not how it works. Both of these tools are going to spin in this direction when they're running. And I'll just show you briefly. This is what is called a downcutting end mill, and I'm going to spin it the way the tool is going to spin it, and you'll notice the shearing action is such that it's going to be shoving stuff down. Conversely, an upcut end mill is sort of pulling up. What this boils down to is this tool is going to be better for roughing. It's going to be more efficient in every way. It's going to have a longer life. The standard, if you see spiral carbide end mill of any sort and it doesn't specify which way it cuts, it's an upcut, just by convention. This is generally what you want, except for specialized work. So this thing is going to rough better, it's going to stay cooler, it's going to be constantly evacuating its chips out of the hole and keeping its path clear. The downside to this is, since this is sort of shearing up, it has a way of fraying and tearing up the upper edge, and that's problematic in inlay. We want that upper surface to be real clean and nice. So that's where the downcutting end mills come in. If you only have one type, if you only get one type of end mill, I would get a downcutting end mill. They don't rough quite as well, but they totally they do the trick. They really shine because they're shearing downward into support. So if you're cutting into material here, they're shearing down into support, and that keeps the upper edge really nice and clean and crisp. So they are not quite as good for roughing. They will get a little bit hotter. They don't last quite as long. They are particularly unhappy if you plunge them straight in like a drill. You'll always kind of want to ramp them in, and I'll show that once I get it in a Dremel. But it's important to be aware that you have these options. If you're ever using a more standard end mill looking thing and it's an upcut and it's fraying and fuzzing up a bunch of fuzz and you can't see your cut lines and it's chipping stuff out at the top, you just need to get yourself a down cutting end mill and you won't have that problem anymore. All the same rules apply for different diameters. There are upcuts and downcuts, and generally speaking, I like to have primarily downcuts on hand with an upcut 1/8 inch or two, and I'll rough out the middle of an inlay real quick and easy with the upcutting end mill, and then I'll finish off the periphery where I'm concerned about it being clean with a downcutting end mill. This plastic sleeve thing here is kind of interesting. This is something that CNC operators appreciate if they're breaking these tiny tools all the time and they want to quickly load another tool. These little collars have been put on not only to help you identify which cutter is which, but they have a very precise distance from the back of this plastic sleeve to the very tip of the cutter. And what that means for you, and I appreciate it even as a Dremel user, if I take the time to set up my router base to a very particular depth with my 1/8 inch end mill, with that collar butted all the way up against the collet nut, I can pretty quickly and easily, without messing with my router base, loosen this, take it out, and load a different tool, and it should be pretty consistent. It will at least be real close in terms of depth. If you ever come to find that those are bothering you, just clip them off. They're just hard plastic. You can totally just clip them off of there. So as far as loading a tool into here, something I'm going to skip right now, but I'll mention the only downside to this impeller fan is that it does not go through the threads that mounts the StewMac router base to the Dremel itself. So I'm going to skip that step, but just know that you'll have to put the base on first and then load the tool. So here we have the spindle lock. That's going to lock the spindle and let us actually put torque on this nut here. So I'm just going to push the Dremel, the end mill rather, all the way into that collet nut, and I'll even keep a little bit of tension on it as I snug this nut up. I just felt my lock engage, and I come to find that there's no need for the wrench, particularly when you have this collet nut fan. Like real tight with your fingers, I've always found that to be just fine. If you're having Dremels come out, or you don't trust that your fingers are strong enough to get that tightening going on, feel free to use a wrench, but use it very sparingly. As soon as you have 2 inches of mechanical advantage on this, like just a tweak with 2 fingers on the wrench is fine. My philosophy is if it's too tight to get off with your fingers, it's plenty tight enough. You do not need to be white knuckling the wrench and chewing up the collet nut and wrecking the wrench. So we'll lock that in. If you have end mills that don't have that little sleeve, you tend to want to put them as deep into the collet as they will go. You want to avoid hitting the bottom. So if you put it in all the way and you feel it hit the bottom of the taper there, you'll want to pull it out just a little bit. And you also don't want to let any conical features, any flutes, anything that's not a straight up cylinder does not want to go inside the collet. The collet does not want to grab onto anything except for straight up cylinder. So it's needlessly a needless loss of rigidity if you have it sticking out a ton. You also don't want to have it jammed all the way into the bottom. So if you put it in all the way and lift it up a 1/16 and snug it down, you're going to be keeping this tool as stiff and rigid and long-lasting and accurate as possible. And conversely, if you wind up with a short tool and it never hits the bottom, don't be putting tapers or flutes or relief grinding or anything like that into the actual collet itself. So some people find it pretty frustrating to adjust the depth of this base. So I'm happy that I have this sort of simplified example of the same sort of philosophy here. The tool is firmly snugged into the collet with that rubber or plastic sleeve all the way against the collet nut. Since I have it, I'm going to go ahead and rough out my pocket with an upcut bit, and once I get closer to the edge, I'll switch to a downcutting end mill. So as far as adjusting the depth, I need to be adjusting the depth based on how thick my actual inlay is. So I'm going to have a pair of calipers handy. Eyeballing it like this can give you it's kind of a decent starting point, but I'll show you how to use calipers to get it right on the money. All the springs and stuff going on here can be a little bit confusing, but the mechanism is exactly the same here. What you have to imagine is that you ultimately have like a threaded bolt, 4 nuts that thread onto that bolt, and I like to just imagine this as a washer. So this plate here, that the real big one that says Stumac, it is not threaded. It's totally ready to just slip and slide up on that on the rod there, and you're controlling where it is, and you're controlling its parallelism with the base by way of pushing it around with this nut here. And it's standard thread, righty-tighty, lefty-loosey. And my preferred way of just making this a quick and easy process is if I decide, okay, it needs, my depth is not quite right, I've checked it with the caliper and I need to make it deeper, what I'll do is just sort of get one out of the way, just get it out of the way, loosen the other one, scoot it forward until I feel like I've made the adjustment that I want, and then I'll close all of them back on it. It's important, it's really, it's very important with this base that I don't let this sort of thing happen. See how I'm just torquing that out of parallel? This is squeezed down here now and it's not so good. The springs and whatnot on here are intended to help you avoid that, but if you're not paying attention and you are crushing one side and you didn't move the other side out of the way, you'll wind up with a nasty condition like this where you're hurting the base and your tool is not perpendicular to the surface here. You don't want that. So I clearly have way too much cutter sticking out here. So what I'm going to do is I'll just loosen both of the big ones, and I'm just going to get this guy out of the way. I'm going to get this one out of the way, and then I'll make my adjustment here. Notice how it's kind of automatically adjusting over here just because I've given it space, and the spring tension on here is going to keep things parallel. Alright, so I ran out of travel. So again, my preference is kind of to do the adjustment on the spring side, keep the non-spring side, just keep it out of the way, just give yourself a gap, and if that gap closes and you're not where you want to be yet, just open the gap up again, just save snugging this side until the very end. I think you can probably see that cutter is getting to be closer to the thickness of our part that's going to go in. And I'm going to take this away from the camera and look down it real nice and get it as close as I can visually just to the top of the part there. And then I'll show you the next step to know that we've got it spot on. So I've got it visually as close to my target thickness as I can. I've snugged up this side, and now I just need to snug up this side without twisting these two surfaces out of parallel. So I'll just sort of come in and gently make contact up there, gently make contact down here, and then I usually, as a final thing, if I'm ready to make a cut, I'll do my final sort of snugging up with the big knobs. And now we're ready to make a test cut, measure it with our calipers, and adjust from there. So we're ready to make a test cut here. I could do that in the middle of my pocket. I'm going to opt to do it on something I know I'm going to be cutting off, or I'll do it into my bird's mouth or some scrap piece of wood. It needs to be something that's relatively flat. This brings me to an important point. There's a strong compulsion sometimes if you're new to this type of tool to get really close to your line and then think, oh man, I'm getting close to my line, I want to slow down and be more precise, so I'll turn down the RPM of the Dremel. That's not a good option. It does not make the Dremel go slower. It does not make the cut occur slower. It makes the cut choppy and jumpy, and it makes the end mill not cut properly. So for end mills 1/8 inch and smaller, max RPM at all times is the way to go. Full throttle is where these end mills are going to be happiest. And I'm going to opt to just come in and take a little bite out of the edge at this depth. This surface is going to ride on this surface, and I'll be able to measure with my calipers real accurately exactly how far that cutter is sticking out past this base. And not surprisingly, I'll be able to measure my part thickness and make a really educated guess on what is going to be most advantageous when I actually go to cut the pocket. I have a strong preference to never turn the Dremel on or off while I'm in the cut, while I'm in the pocket. I try to not do anything while the Dremel's spinning and I'm in the work. I don't want to be adjusting my lamp. I don't want to be pulling my chair forward. I don't like to do anything except for be 100% focused on the tool while it's running and it's in there. So if I come to find I don't like where the lamp is, or I'm ready to have a closer look or pull a measurement, I'll just tip it out of the cut, lay it on its side, turn it off. There's another strong temptation to think that, hey, that's a nice base there. I'll just go ahead and set the Dremel like this. That's a great way to break the tip of your end mill off. Don't be sanding it up like that, because obviously that cutter is sticking out past the tip, past the base here. So that cutting end mill left a little bit of fuzz that I'm just going to quickly knock off. I've got my calipers here and I've got them nicely zeroed. I'm going to take advantage of the little probe end there. I'll be sticking out the probe too far. I'm going to stick that probe into the bottom of the cut there, and then with the caliper as vertical, as perpendicular to the surface as possible, I'm just going to come in and let the floor of the pocket of what I just cut push the probe in. So 49 thousandths. That's how deep that is. Never a bad idea to see if I get the same number or real close to the same number every time. Okay, so I feel like that's confirmed. Right now that cutter is sticking out 49 thousandths. I'm going to have a close look at these parts, keeping in mind that they have paper on them that needs to come off, so I want to kind of account for that. They've also got blobs of glue. So huge discrepancy there as I'm sitting on the glue. I think I'm pretty happy with that as a depth. I would rather this part be sticking out just a little bit than have it sunken and have to chase the whole surface down to it. So if that's 49 thousandths deep, and this material is 54 thousandths or so with the paper on it, I'm setting it up to be scrape off the paper and maybe have 1,000th or so of material to scrape off to bring the inlay down into flush with the rest of the substrate. So I think that that's about right. There may be times when you would want to sort of flip that relationship. If this was stainless steel for some god-awful reason, I don't recommend you work with stainless steel, but if it was and you don't want to level it, which you don't, you might opt, if it was a small substrate, you might opt to leave the stainless steel a few thousandths low and bring the substrate down to it. Conversely, if this is a piece of wood, or it's all wooden components and it's going to level pretty easily, I'd be real bummed if I cut too deep in a gigantic tabletop or bench top, because now I have to bring the entire surface of the substrate down to that inlay. So think carefully about what you think would be best, and ideally you don't leave yourself more than a few thousandths of material to remove in either of those cases, whether you're bringing the substrate down to the inlay or the inlay down to the substrate. Pick which one of those is going to be best, and don't overdo it. So I've got my depth set, I've got my piece firmly clamped down, I'm ready to go ahead and come after this thing. I'm going to opt to start in the middle, not surprisingly, and I'm going to systematically kind of work myself out until I've got perhaps a 1/4 inch margin all the way around, and then I'm going to look to very consistently turn that into an 1/8 inch margin, real consistent with all my border lines here. And I want to sort of shrink that up in parallel, taking my time to get to know the different areas that are going to be tricky, maybe places where I'm going to struggle to see, or the grain is inclined to pull the tool in one direction or another. Before I dive in, I'd like to just describe something that's bad for end mills. So this is called a mill, and while it looks very much like a drill, they serve very opposite purposes. Drills like to cut straight in. That's what they're for. They cut axially along their axis. Drills like cutting along their axis. They do not like cutting radially, sort of out from their center. Mills are exactly the opposite. They love cutting laterally like that, cutting radially out. This is fantastic for pocketing. It should be noted, however, that end mills, particularly down cutting end mills, do not like cutting along their axis. So if you were to come in and plunge this straight down, the tool will get super hot and it's angry and it shortens its lifetime. So to avoid that plunging motion straight in and treating this mill as though it's a drill, because they don't care for that, I will oftentimes just sort of do a spiral to basically let the tool pretend that it's cutting radially the way that it likes and very minimally on its tip until I get to the depth, and then I'll be cruising out to my borders here. Another thing that end mills prefer is to not be fully engaged. So if you take an end mill and just run it straight into the material, you're cutting on 50% of its circumference, and it's going to be having a hard time. It's going to get hot. The cut won't be great. The end mill won't last quite as long, and if you're sneaking up on a line, that's not a good way to do it. So I will oftentimes sort of get into a groove where I'm spiraling out, only keeping a small percentage of the tool's cutting circumference engaged in the work at any given point, and that's going to give me the best ability to make very small adjustments. I'm also, if I don't like the way a particular area feels, I'll just sort of get to spiraling the other direction and just get to know this piece really well. So I'm going to have a lot of chances to get to know which way I want to be going and how grain feels, and ooh, that's a nasty spot, watch out there. I'll have a lot of chances to get a feel for that before I actually come up and try to make half that line disappear. So I'm going to go ahead and go for it. You'll see me do a little spiral thing to enter, and then we'll get this thing pocketed. So we're off to a decent start here. You'll notice how I sort of spiraled that end mill in a circle that was perhaps twice its diameter. That is going to keep the end mill from trying to burn up, from being plunged straight in and treated like a drill. You'll also notice how I didn't just plow the tool through here. I sort of took little spiral bites, and that keeps the tool cool and keeps the cut sort of reasonable. So another thing, I think you can probably see in the camera, this edge is pretty nasty. The upper edge there, I'm using an upcut end mill until I get a little closer. I would be pretty bummed if I was leaving this kind of surface, this fuzz, covering up my cut line as I'm really trying to do precise work and getting to the end, so I will appreciate having a down cutting end mill to finish with. I'm going to go ahead and hog the rest of this out. I probably won't record the whole thing until I get to a nice stopping point. I don't like approaching a line that's on the opposite side of the tool, so I will sort of get as close as I want to here, leaving, 1/8 inch or so, something consistent, and then I'll flip the whole piece around, and I'll always try to be working towards myself. And if at any point I can't see, I will break out a lamp, I'll deal with a flashlight, I'll do whatever I have to do to make sure that I'm not kind of flying blind here. So I think I'm about ready to switch to my down cutting end mill. The bulk of the material has been taken out with the upcut. I've got a lot of fuzz going on here. I think it's time for the down cut. Another thing that I just noticed in sneaking up to an imaginary sort of 1/8 inch line away, these areas right here, that short grain, are much more inclined to shoot off when I finish them, when I'm cutting this side, I should say. So the tool is spinning this way, and if you kind of imagine the forces there, this direction of spinning is causing this piece to want to just chip off and fly away, whereas when I cut this side over here, the force of the cut is kind of towards the outside of the pocket, and it's less likely to blow away this short grain. What that means to me, note to self, when I start getting close here, I'm going to want to finish this edge first. Let any nasty stuff happen out here in the material that still needs to go away, and then I'll finish off the tippy tip of this point on this edge where the cutting direction is such that the material is supported. It's being shoved out into support rather than being shoved into an empty pocket and risk blowing it away. And I'll be switching to that down cutting end mill, taking advantage of the little red sleeve on there, and that should let me get right to a very close, if not identical, depth. Probably it would be wise for me to double check it with the calipers, and I will choose to do that. Another thing that's worth mentioning, there's a strong tendency to, in the same vein as, ooh, I'm getting close, let me turn down the speed of the Dremel. That's a no-go for reasons we've discussed. Another inclination you may feel is, oh man, I'm getting close to the lines, I'll switch to a smaller tool. That will not benefit you. In the same way that you always want to be running full RPM, you also always want to be running the very biggest tool that will fit. And that's going to be the 1/8 inch end mill and pretty much everywhere on this whole design. Obviously the 1/8 inch end mill is going to leave these corners slightly round. I will probably opt to just chop these corners out with a utility blade or this X-Acto here, rather than try to put a tiny end mill to make that radius smaller. If I have a long skinny section, I'll get absolutely everything that I can done with the 1/8 inch before I resort to the smaller tool. In the same way that turning down the speed is not going to result in things happening slower, it just makes things choppy. Switching to a smaller end mill is not going to give you any greater level of control. The small end mills really only excel in fitting places that the large end mill can't. So stick with the biggest end mill that will fit at all times until you get to a point where the big end mill physically cannot go any further and you're left with maybe more than you would like to knife out. That's when you resort to the small end mills, only when you have to. So as you can see, the downcut end mill leaves a much nicer top surface. I'm able to see what's going on a little bit better. In fact, the downcut end mill is a little bit less grabby. It's a little bit nicer to kind of float through here and get a good feel for stuff. I didn't notice that the camera was covered with fuzz when I was talking about the points and which direction I was going to cut them, so quick recap on that. The end mill is spinning in this direction, so clockwise from my perspective, and I noticed that when I'm cutting on this side of these points, the side where the end mill is kind of pushing this piece of short grain in towards the pocket, it was blowing chunks off. And when I was cutting on this side, the force of the cut was pushing material into support. So I'm going to opt to finish these edges first, get snuck up right to where I see that chalk line get sort of intersected with the edge of the pocket here. Then I'm going to choose to finish this edge just to avoid shooting those little chunks off into the pocket. So I'm getting pretty close. I can just tell by looking at it, I'm definitely going to do the whole thing with the 1/8 inch end mill. And I'm coming to find that floating the end mill in a counterclockwise direction has proven to be pretty nice. This makes it sort of do a climb cut and kind of skitter along the walls and keep itself moving, and you can get a nice thing going on. I'm not thrilled with the way I have it clamped right now to where my arms, my wrists can't be on the bench. I'm going to look for a way to clamp this to where I can kind of lean over it and put my wrists and my elbows up on the bench and kind of get a little bit closer to it. But it's getting close. I think I'll bring you back in if there's anything worth mentioning, and if there's not, I will go ahead and show you this once I feel like it's done and I'm ready to start investigating the fit against the actual part. Alright, so I have probably put in a good 90 minutes of work since the last time you saw this pocket, just getting that last 1/16 of an inch. That may seem like a long time, but this is one of those steps where you really only get one shot at it. If you make a big mistake, you're going to need to make big adjustments, make an additional component, something like that. So I really took my sweet time and snuck up on the lines. I'll tell you, I also put a small chamfer on the side of this at about 45 degrees. I talked about that in the hand tool only inlay. That chamfer does not even approach a quarter of the thickness, so I'm not getting crazy with the chamfer, but I did put a little chamfer in there. This part has probably been tested in here, shine a flashlight at it, rock it around a little bit. In fact, you can kind of push and you can feel the high points. If you feel a real strong point that it seems to be sort of rocking on, that can be indicative that that's a place that needs to go. And in fact, particularly where the metal is, if you give it a shove and squeeze it around a little bit, I don't want to break anything and I don't want to shove it all the way to the pocket, to the bottom of the pocket yet. After giving it kind of a rough squeeze in there, as rough as you dare, sometimes you can come in and catch the light off the corner that's rubbing, and that's an indicator that you need to come in and just give a little whisper off of that spot. I did knife out the corners. I never went away from the 1/8 inch end mill, and I will tell you, I probably spent 20 of those minutes with the knife carefully knifing out the corners, and if there was somewhere that I didn't feel like I could be gentle enough with the Dremel, I would come in and hold my knife vertically and come in and just kind of shave the walls. So I think that this thing is ready to go. It is pretty tight. It's not fallen all the way to the bottom yet, and I don't want it to fall all the way to the bottom, or I won't be able to get it out to put glue underneath it. But I am considering I decided that this was going to be wall hanging, so I glued this to another board. If I didn't have this board glued on here, I would probably take the time to make this fit a little bit less snug for fear of splitting the substrate down the middle, but since I have that background piece on there, backup piece if you will, I think I'm ready to go ahead and do this. I had intended this to be a glue up with epoxy, But since I really took my time and don't feel like I made any major mistakes in the pocket, I don't need the gap filling ability of epoxy. I think I'm going to take some wood glue and I'm going to mix a little bit of artist graphite into it. If you watch the hand tool only video, you may have heard me complain that the graphite was inclined to leave stains. I wouldn't mind if there's a slight black line around this part, just because there is a nice contrast between my inlay parts and my substrate. And Purple Heart is a lot more dense and less porous, and it's less inclined to get messed up and take stain like that. So I think a very fine black line would be fine anywhere where I do have gaps. So let's go ahead and get this thing glued in with black dyed wood glue. I'll also mention that I scraped the glue off the bottom of this, and any slight discrepancies and things being at the same level. Scraped it until it was relatively flat. That made the metal shiny, and so a great way to hold onto a piece like this is just to stick a little tape handle onto it, and then I took it to some real coarse sandpaper, scuffed up the bottom, which makes it flat and gives it a strong texture for the glue to hold onto. So we're ready. So I've got all my ducks in a row. I've got clamps. I have a nice flat clamping caul. I've got my non-stick plastic. I have a paper towel on hand. Got a little mixing stick. I've got a little piece of shiny trash that I'm going to mix my glue on. I've got some Titebond 2. I've got some artist graphite. So my plan at this point is to squirt some glue onto here, mix some graphite into it. If I struggle to get that mixed or I feel the glue is setting up, I have a little spray bottle with water, and I'm just going to give that a couple drops of water and thin it out a little bit. That'll make it flow a little nicer and give me a little more time to work with it. That's fine. And I'm going to smear that into the pocket. I prefer to just use way too much glue rather than worry about not having enough, so I'm going to smear it in here, being sure to get it up on the walls of the pocket. Gave myself another witness mark just to be sure that once this is a gluey mess and I can't tell what's going on with it, I know which way it goes. Those chamfers give it a pretty nice, like it goes halfway in. It's definitely, it knows where it's supposed to go. I'm then going to set the clamping caul on top of it with the plastic. I'm going to crush it under the clamps, give it maybe 60 seconds or so, and then I'm going to take the clamps off. I'm going to wipe off some of the glue with a wet paper towel, and if I see anything that I don't like, I'm going to consider coming in with the butt end of a screwdriver or something hard and shoving those areas down. I'm going to come in and kind of make sure that everything is down all the way. This surface is not perfectly flat because it's got blobs of glue all over it. And if there's anything that I shove down and I see squeeze out, and when I take the butt of a tool off, it comes back up, that's something I'm going to maybe assume is not getting held down because it doesn't have as much glue piled on it. I then have just a Scotch-Brite pad. I'm going to put this over the top of the plastic underneath the caul as something that will give me a little bit of give, and it will crush, and ideally it will sort of transfer the clamping force everywhere to hold down any stray areas that may be trying to pop up. Yeah, I think I've got my bases covered, and we're going to go ahead and glue this thing in. Enjoy. I'm pretty happy with what I'm seeing here. I actually came to find a few defects in this substrate that I failed to scrape out when I was prepping it, so I actually set my Dremel deeper than I initially said because I'm okay with bringing the substrate down to the inlay to some extent. These funny dots you may have noticed was I was feeling cute when I was applying the super glue to the seams, and I decided, just in the interest of keeping this thing semi-flat, I put a couple of drops where there was no cause to have them, just so there'd be more to push on. I don't see any places that concern me. Everything seems to be going down pretty nicely. Wiped it off with a wet paper towel. I think this thing is fit to have some plastic thrown back over it. I think I am going to go ahead and leave it for the longer clamp with something that has some give, a piece of cardboard or even cardstock, something that's going to kind of shove down in there and accommodate for the weird weird height in there is going to be fine. And I'll probably leave that clamped for 20 minutes minimum. I think I'm about done for the night, so I'll probably leave it clamped up overnight. We'll bring you back when it's dry. So this thing dried under clamps for hour and a half. When I took the plastic off, I decided I thought there looked like there was some thirsty spots in there, some lines that probably could stand to get filled with a little more glue, so that's exactly what I did. Just whipped up another batch of wood glue with the graphite in it, and just squeegee that on top. That is going to make for a little bit of extra mess that I have to scrape off. However, I think it will lead to less voids and bubbles and things in here, so I think this thing should be pretty full now, if you will. And if you recall, I mentioned that I sunk this inlay a little deeper than flush on purpose. I want the ability to take this surface down to it. So leveling this is going to be a little bit different, but the goals are still the same. All said and done, the only acceptable way to be is dead flat across the substrate and the inlay, and not have any bumps or funny mounds wherever there's hard material, and that's inclined to happen if you don't resist it. So I'm going to level this in fast motion. I would kind of prefer to use a hand plane on this, but I don't actually have one on hand right now. I think I'm just going to scrape off the bulk of this glue, being sure to not dig a groove right here, because I'm going down to the inlay. The inlay is not sticking up. The substrate is above it. And we'll have a separate video on my philosophy on scraping down a tall inlay. A proud inlay, rather. Alright, so I'm going to stop scraping at this point until I have access to a proper vise that can hold this piece down for me without being in the path. I'm worried about digging a low spot right here. Something I'd like to point out, well, two things. This is a pretty interesting tool. Just got this at a big box store. It is carbide tipped, and you can buy replacement blades, and the blades are two-sided, and they are pretty wonderful. It's pretty epic to have the ability to put both hands on it like this. Same rules apply as the StewMac scraper. There's really no reference except for the cutting edge itself riding on the surface. So you'll notice I was checking it pretty often with the straight edge to make sure I wasn't doing anything crazy. Another thing to watch out for is I would recommend buying the flat version of this. They have a version with camber, and then they have a flat version. I like the flat version, and you do need to watch out that you don't dig these corners in. This is a real aggressive blade, and when you've got two hands on it like this, if you get wild and present a corner to the work, it's going to make a big ditch. Something else I wanted to call your attention to. I don't think this is a huge problem, but it's worth making a mental note of. So we have black glue here. We're starting to hit paper in some locations. You can see the funny little blobs of super glue I left out just kind of for fun to act as something to be pushed down by a flat clamping call, just so these areas would get pressure. I noticed that, and this is always worth noting anytime you're leveling any inlay, this wood and this copper is showing. And I've still got places where I'm not even through the paper yet. So what does this tell me, and why do I want to make a note of this? That tells me that this area didn't go down to the floor of the pocket, and if I really get wild and just throw caution to the wind and level this thing too much, this is going to be the first area to disappear. So you want to kind of make a note to self, okay, I'm going to add to my memory banks how tight this inlay felt, and the fact that I clamped the daylights out of it and even pushed it with the butt end of a screwdriver. This area still sort of rode up the walls, didn't quite go down all the way. Probably either should have found a way to apply more pressure there, checked it more carefully once I first took the clamp off, or made the fit slightly looser. Again, I think this is going to be just fine, but note to self, I want to watch out a little bit, because this piece is off the floor of the pocket, and therefore that will be the first spot to break my heart if I go wild and just take this surface down without paying attention to what I'm doing. So yeah, I think we'll discuss more of these things in a leveling specific video. Thank you for your time.